Hello and welcome back to Elementary Algebra, section 3.2 on equations in two variables. So this lecture is going to give us more info on calculating values and give us some connections to the situations that are experienced in the world around us and stuff we can compute. It's not too long of a lecture, which means that after this lecture, those of you that stay connected to Zoom will have option to ask questions in terms of, exam prep and so on for this weekend. Now let's go and talk about equations in two variables. So we know that the variable x was something that we used to compute earlier in those equations. And every equation, I'll just call this old, right? Every equation from before had the one variable only, and you can solve the equation for that variable to come up with the answer, in this case x equals 8. So this particular equation had one variable. So that's it, only one variable in this equation. Now, what we are going to look at are equations that have two variables, which means you can calculate two things. And we actually have seen one of them already. Remember the conversion for temperature? So Fahrenheit equals to 9/5 Celsius plus 32. This is two variables. You have Celsius and Fahrenheit, two different temperatures. So if you want to calculate one temperature given the other, you can do a quick calculation. So one of your questions, right, I believe homework, or we did it during the class, whatever, was to convert, let's say, 25 degrees Celsius into Fahrenheit. So how much is 25 degrees Celsius in degrees Fahrenheit? And you will do that by simply plugging this 25 for C, and you can calculate the equivalent temperature in Fahrenheit. So that would be 9/5 times 25 plus 32. Now I'm going to ask you to, do this calculation, and then I will do the problem, once you guys are done. So try this calculation, which is more, the order of operations. So does anyone have the answer?
Is it 77?
All right, let's take a look. Hopefully it is. So we're going to cancel 5 and 25 and get a 5 in here. So all I need to do is 9 times 5 plus 32, which is 45 plus 32, which is 77. Awesome. So the 24 degrees measured anywhere else in the world, right, is 77 measured in the United States. So now what you have seen up there is the equation that has two variables in it, and then you know what each variable represents, and you can use that to calculate.
Okay, I need
the other way.
help.
Yes.
So I'm here at the bottom line, 9.5 plus 32.
No,
How
it's
did
9 times 5.
Oh, 9 times 5.
9 times 5 is 45.
Oh, okay, got it.
Because we cancel the fraction and then that 25 becomes a 5. So other equations that you have for, if you have two variables, for instance, let's say you can calculate the height of the object if you drop it as it falls. That's another funny calculation. So you can calculate the height of the object would be, let's say, negative 16.1, and then you can say over here t squared, and then say plus, and let's say you dropped it from 5 feet height. So here is you dropping an object, or let's drop it from 4 feet usually. Okay, let's say 4 feet or 3 feet, whatever. So this is equation that has two variables in it. You don't need to know this equation from physics, but you need to know how to compute the equation, because if I can ask how far above ground is the object um, 1 or 2, let's go 2 seconds after we drop it. Oh, this is not going to be good because it's going to give us... Okay, let's go half a second. Would that do it? No. Quarter of a second. Yeah, things fall fast. 4 feet. 1/4 of a second. Okay, so how far above the ground is the... Well, this is the height of object. Height above ground. And this is your time in seconds. So all you need to do is to plug 1/4 for t, and you're done. So all of the equations in this section have two variables, and all you need to do is to plug in your number and calculate the value. So let's go and take a look. So I have height is equal to negative 16.1, and then I have my 1/4 of a second squared plus 4. And we just use PEMDAS like always, right, before. All you need to do is to square 1/4. So that's going to be negative, we don't even have to have 16.1. Let's just use 16. It's fine, 16. So negative 16, and then this one turns out to be 1 over 16 plus 4. And I deleted that plus 1 because now we have a nice fraction we can cancel. So 16 and 16 cancel completely. And you get your height is negative 1 plus 4 is equal to 3 feet. So in 1/4 of a second, this object...
Okay, I need help.
Fell down 1 foot. Yes.
So I'm at the first line up here, h negative 16. divided by 1/4 squared.
It's times 1/4 squared.
Okay. Times 1/4 squared plus 4.
So 1 squared is 1, and 4 squared is 16.
Okay. So if you have 1/4 squared,
You square each number independently.
oh, okay. So you square the numerator and the denominator separately.
Yes.
Which will give you 1/16. Okay. Okay.
We good?
Yeah, do you mind not going as fast moving forward?
Well, we're going to now go off of these word problems and do some of the ones that have no meaning. So we're going to now take a look at something that is just numbers, where you just get to plug in a number and take a look at it. So let's say you have the one that is listed in the book. So problem like this has, as I said, just x and a y. So it's, we're talking in general terms here. And we want to now check what is y if x is equal to, let's say, 1. So you're supposed to obviously plug in x equals 1, and you can compute y. So I'm going to give you some time to get that calculation done. And if whoever is done, you can just say the answer, and then others can check.
It's 3.
It's 3. Okay,
Yes.
well, I haven't done it, so I don't know. I can check actually by placing 1 in here, right, and see if and placing 3 at the same time. But I'm going to solve it the same way you guys solved it. So I'm going to say 2 times 1 minus y equals 5. That's 2 minus y equals 5 when I multiply 2 times 1. And now we subtract 2 on both sides. We get negative y equals 3. Y is negative 3. Is it?
Yeah.
Yeah.
Y is negative 3. And you can check by plugging in both of those numbers. So 2 times 1 minus negative 3 should be 5. So 2 times 1 is 2. Minus and minus gives us plus. And there it is, 5 equals 5. So we know this is good. let's take a look at table of solutions, which is, again, this is just
How did we get that to be a -3 from negative y equals 3?
we divide by -1 the same way we did in the previous in chapter 2, right? You have you need to get y alone, so you divide both sides by -1. And if you divide by a negative for those inequalities in 2.6, you have to switch the sign of the inequality. That was the extra step that we had. But this divide by negative was always that step doesn't change because you need to get a positive y on the left. Cool?
Cool.
Woohoo.
So a positive divided by a negative is a negative.
Mm-hmm. That is correct. And the negatives would cancel on the left, which is why we divided by a negative, right? To cancel that negative. But on the right, we have a positive divided by negative, that's negative. So division and multiplication have the same rules. So when you divide or multiply positive and negative, you always get negative. And if the signs are the same, you always get the positive. So positive, positive, and negative, negative give positive. And if you have one of each, whether it's multiplication or division, you always get a negative. Those are the rules for multiplication and division of signed numbers. So now for this chart of values, I'm just going to lift a problem from homework, which is what you guys are going to see many times in your on my MATLAB, right? They give you equation 3y plus 2x equals to 6, and then they give you the chart of x and y values where they give you these y values, -2, 0, 2, 4, and 8. And you are supposed to calculate x's. So it doesn't matter, right, if their x's are given or y's are given. The idea is to, whatever is missing, you have to compute that variable. So since y's are given, you will be plugging all of these numbers one at a time. So technically you have 5 problems to solve, independent problems. You will be plugging the y value into the y and computing x's, and then place those numbers one at a time on top. So we have 3 times -2 plus 2x equals 6. So this is where we start. And you can now solve this equation to compute x using your standard rules from chapter 2. And whatever number you get for x goes in the first bin or a box or cell, whatever. So 3 times -2 is -6, plus 2x equals 6. Then we add 6 to both sides, and we get our 2x equal 12. We divide by 2, and we have our first x, which is 6. And we solved the first one. Now rinse and repeat. Plug in 0 instead of -2, and recompute everything to get x equals a number. So you have to restart the entire calculation. 3 times 0 plus 2x equals 6. And then calculate x. Then restart the problem again and plug 2. So I'll give you some time to practice that. I should play elevator music now. Does anyone have a second number?
3.
3, yes. Okay, good. 3 is the second number.
The second one would be 0?
You mean the third one?
Yeah, the third one.
Okay, so 3, then 0. Okay. Maybe I should. No, let me actually plug them in. So that's going to be a 3, and then the next one is 0. So the entire section is plug the correct number into correct variable and then solve it correctly. I use the word correct many times, but that's okay.
It's a long process.
Mm-hmm. Well, everything should be correct, right? So.
Is the next one -3?
Yes. And without solving, can you tell me what the last number is?
-6.
Perfect. It's always a pattern. When you have equation like this, we will call this linear equation later on, and this is one of the forms of y equal mx plus b. Probably stuff you have seen at some point before. So these types of equations always have that kind of pattern in their answers, that they always increase or decrease by the same value. So as soon as you establish the jump of -3, like a -3 thing, you can just keep going -3, -3, -3, -3, and you can generate as many of these as you want. All right, so I'm going to solve. Yes? What was that? I wasn't sure if it was a question or a comment. I can't make it out what you're saying. You can type it in the YouTube chat. Because the lecture is live, and then I can pick it up from there. So I'm going to solve a random one. Let me just finish this one. So now 0 doesn't do anything, so we don't even have to write it. We divide both sides by 2, and we get x equals 3, which was the second one. And let's solve negative 6, for instance. So 3 times negative 6 plus 2x equals to 6. 3 times negative 6 is negative 18 plus 2x equals 6. Now we add 18 to both sides because we are trying to get to x, right? To get there to be alone. So we have now 2x equal, wait, something is off over here. 24, x equals 12. Oh, I was supposed to plug in 8. Terrible. Terrible, terrible, terrible. I was supposed to plug in y value. See, y value is 8. And the result I get is supposed to be negative 6. Okay, so that's 24 plus 2x equals to 6. Then we take away 24 on both sides. And we get 2x equals negative 18. And now when I divide, I get negative. Now what now? When I divide both sides by 2, I get negative 9.
Yeah, that's what I got for that one too. I thought it was wrong.
Yeah, I thought mine was wrong too. I got the same answer.
It's a negative 9. Oh, they skipped the 6. It is a pattern. It is a pattern of subtracting 3, but you can't skip the values. You see how they skipped 6? Because if you go every even number, right, then after 4 you should have a 6. The 6 will give us a negative 6 up there. And then the next number is 8, which will give us negative 9. So the pattern is preserved, but they skipped one value in the chart. So if we had a negative 4 on this side, the number would be 9, for instance, because it would, but you have to go negative 4, which is the next even number. The chart has to increase the same way in order for the answers to increase in a pattern. And if you start skipping numbers, then answers, right, would not. I mean, they still keep the pattern, but you don't see all of the stuff you missed. Let's practice one more of these because this one went so wrong for me. So all of these examples in a textbook, if you're looking at extra exercises, are 21 through 28. So let's literally pick any one of these. 3x minus 5y equals to 30. And again, they give you the y values, and they want you to compute x values. So y values are given as negative 9. Okay, now they didn't skip any. As you can see, they did not skip any of these values. It's always, right, plus 3 for each y. And then you can discover what those values would be for x's once you plug all of this stuff into y. So I'll give you a few moments to practice this. mean to compute? If you are done with the first number, just let me know whenever you have a value.
-5.
Yes, I did this on the side, and I also have -5. So I would agree. Does anyone have a second number?
I got 20 for the next one.
Oh, I'll have to unfortunately disagree right there. Check the signs, just in case.
Anyway, we can go over the first one, then where x equals -5.
Yes.
Thank you.
So the first one, we are going to plug in a -9 into y. So we have 3x and then -5 times -9 equals 30. So -5 times -9 is positive 45. And then we subtract 45 to get x alone. So 3x is equal to -15, right? Because you are subtracting bigger number from smaller. the answer would be negative. And then when we divide both sides by 3 to get x alone, finally, we get x equals to -5.
I was flipping it. I was putting the -9 into the x by mistake, so I got it wrong.
I did the same thing.
This is exactly what we are practicing in this section. So just that one part of being careful where to plug in. We already know how to solve every problem because we are not learning any new techniques. We are only going to now realize that we have multivariable equations, and then we have to be careful where we plug our numbers. So x is for x and y for y, and in those first examples that I used, what you would call real life situations, right? I used age for height and t for time and so on. So, I mean, I don't know, but in my head at least, all of these problems are easier when they actually have the real life scenario of me plugging in values for, height and weight and, time and all of that stuff. So for me, that tends to, because it makes more sense. Now, everyone
I'm
is
sorry,
different.
a negative divided by a negative multiplied by a negative is a positive.
Mm-hmm.
A negative multiplied by a negative is a positive.
Yes.
For the next one, would it be 0?
Yes, 0. I agree on the next one to be 0.
And then plugging in -3 gives you 5.
Yes, then the pattern would take over as well. Yes, very good. So
And
now
then 10 and 15.
10 and 15 would be the next
Yep.
last two numbers because of
Yep.
their of the pattern. Yes, because we didn't skip any numbers now over here. On the bottom, it's always +3, +3, +3. So when the numbers in one of the two variables go in order in a pattern, whatever, plus, minus, whatever number, then the other variable has to go also in a pattern by whatever amount it goes. So as you can see in this particular problem, one goes in a pattern of +3 and the other one goes in a pattern of +5. And that was just for this problem. Every problem will have its own situation. So now if you go to the previous problem, this was -3 and this was +2, right, in terms of the pattern. So there is always a pattern, but you are not allowed to skip in the pattern. And they did have a skip over here. They skipped a 6, which is why I wrote the wrong number up there because I wasn't paying attention. Let's solve two random ones over here. So let's solve. So we did -9, right? Let's do -6 to show that we do get 0 to establish that pattern. And then we can do 0 or 3 to verify. So 3x plus 30 equals 30. And when you subtract the 30, you get 0. You get your 3x equals 0. And when you divide 0 by 3, you have still x equals 0 because 0 divided by 3 is still 0. That's like splitting 0 3 ways. You know, that non-existing cake on a table right now. If you split it 3 ways, everyone gets a 0, right? 0 slice. So when we plug in -6, right? When we plug in -6, we get 0 for x. That's great. And let's try this -5 times 3 equals 30 to get that 15. -5 times 3 is -15. And then to get x alone, we need to add 15, which gives us 45.
Wait a second.
Yes,
Isn't the y supposed to be -3?
I'm working on the last case.
Oh, you're on the last one. Okay.
Yeah, I just want to verify. I'm not solving all 5 of them. They're all the same calculation. I just did the first and the second, established the pattern, went 5, 10, 15, and I just want to check the last one to see that it actually ends up being 15. That it's correct. And it is, right? When I divide 45 by 3, I do get 15. So that checks out. And we know that all of the numbers are good. Is this making sense? Plugging values in?
What?
So now
Is this
let's...
still 3.2 equations and 2 variables?
I'm sorry, what was that?
Is this still 3.2 equations and 2 variables?
Yes, we're not doing anything else as a new material. We're just doing this equations with 2 variables. So we plug in one of those 2 and we calculate the other one. That's all we're going to do in this section. So now a lot of problems here ask you to, well, let's also write, it's not a formula, it's more of a, like a definition of this linear equation in 2 variables. So in terms of like what it looks like. So linear equation in 2 variables looks like this: ax plus by equals to c. And we try not to have fractions here. We like to have whole numbers. You could force fractions and decimals, but you can always get rid of them by multiplication. So we try to have a and b as whole numbers, and then, I mean, you can have all of them, a, b, and c, as whole numbers. So even if you have fractions, you can use that trick I taught you earlier in the course, when you get rid of all of fractions by multiplying the common denominator on the both sides of the equation. So this is what pretty much all of the equations in 2 variables would look like for us. Even though we know that there are equations that contain x squared and all of that stuff, but that's also for later in mathematics. Now we're focusing on these linear equations. And once you have a linear equation, let's say 2x plus 9y equals to 12, whatever, 2 questions that you can get on your homework are solve for x or solve for y. So these are the questions that you can get, and this would be equivalent to those questions you guys had in 2.4 called formulas, where you had to flip an equation to solve for the variable that is asked in the problem. So if I, let's say, want to solve for x, that's going to be orange, and then solve for y, it's going to be blue. We have two problems here. So how do I solve 2x plus 9y equals to 12? How do I solve that for x? What does it mean, solve for x?
On the value of x.
Well, we can't find the value because we don't know what y is. We can't find the value of x, but what we can find when it says solve for x. What is the goal?
Is to get x alone.
Excellent. Perfect, perfect, perfect. Yes. Solve for x means get x alone. Solve for y mean get y alone. So now if I want to have x alone, I have to get rid of 9y. That would be the first step. So here I am getting rid of 9y. Now 12 and 9y are not like terms, so I can't combine them. I can just have this as 12 minus 9y. There is nothing I can combine there. And finally, divide both sides by 2 to get x alone. So our goal is to get whatever the variable, whatever problem asks you for, to get that variable alone using those methods of removing things that you don't need. So this, as you can see, this is solved for x because you have x alone, right? So get x alone. Now the blue problem is get y alone. I'm going to give you a few minutes to try that, and then I will solve it on the right hand side here of the right hand side of the screen. So try to solve the same equation, right? So you are still looking at the same 2x plus 9y equals to 12.
Wait,
And you
what's
are now
the
trying.
answer for 12 minus 9y divided by 2? Did you write an answer?
Yeah.
That is the answer, right?
Yes. That's
Yeah.
the answer because x is alone. Now we don't have a value of y, so we can't compute the number. We were able to come up with the equation in this case because we didn't have the value to compute. So solve for x is alone, and that's how far we can go. We can't go anywhere else because we don't have the y. And now in blue, we do the same thing except flipped.
All the answers are gonna come out like an equation like that.
Because you don't have value for x, you can't compute. This is usually where people start checking out for mathematics. They said, what do you mean my answer is equation and I don't get the number? Does anyone have the answer? Y equals?
Is it 12 minus 2x over 9?
Excellent. Perfect. So the steps are exactly the same as before. You want to get y alone, so you have to get rid of x. So we're going to subtract 2x on both sides. And that is going to leave us with 9y equals to 12 minus 2x. We cannot combine those, right, because they're not like terms. So we just have to write it as 12 minus 2x. And then to get y alone, need to divide 9 both sides. And when 9 cancels on the left, leaves the y alone, and that is the answer. Y equals, so we solved for y in terms of x. And this is one of the most important skills of mathematics because later on we want to simplify expressions and we want to simplify equations and then solve for the variable that we need. And equations are eventually going to start having more than 2 variables, so we definitely want to navigate through those to be able to calculate certain things. You know how people are self-conscious about the weight? I would never understand why, but whatever. And now we also, you know, even the people who don't care need to be sensitive about the thing because of whatever. If there is a body mass index, which is a multivariable equation, which uses the age and the weight and the height and a whole bunch of stuff, right, to calculate. You can find out a lot of personal information if you're able to manipulate that formula. You know the BMI, right? So a lot of stuff that you can do with these multivariable equations, but we are now only dealing with the 2 variables. So let's take a look at what type of word problems we can see which would only use 2 variables in this case. So there is a model that calculates US population. And this problem says that the population of United States is equal to negative 0.025 t plus 60.35 for years 2010 to 2050. Now, this is where you get to see, projected. So I have to read the whole problem now. So US population. For the years 2010 to 2050, the projected percentage P of the US population that will be 18 to 24 years old during the year T. Aha. So P is not the population, P is the percentage of 18 to 24-year-olds. Okay? So 18 to 24 years. So, you know, it's technically, you know, college age, let's say. So you can pick any year you're interested in. Plug it for T, time, year, right? Plug it in for T, and you will get what percent of population will be 18 to 24 years old. So now give me 1 year, anyone. What year you would be interested in?
2050.
2050. Okay. So if time is 2050, right? Then we are going to plug that value. Oh, I should say P equals, percentage equals, there we go, negative 0.025, and then you put your 2050 over here, and then you add 60.35. So now you can multiply this in your calculator. What is the number that you're getting for it?
I got 9.1.
That's the total answer.
51.25.
Yes. So negative 51.25, and then when we add 60.35, we get that the percentage is 9.1%. This means that 9.1% of all people in United States will be 18 to 24 years old. Now, are you expecting that number to be, that percent to be bigger or larger in, let's say, 2020? Because we are going to calculate also 2020. What do you think? You're expecting the number now to be bigger or smaller?
Smaller?
Let's see. Why would you expect smaller?
I'm just guessing.
I was guessing maybe because I guess the way technology and the future's moving forward, people are having less kids. I'm not entirely sure.
That's actually a very good prediction, because a lot of people would make a mistake and say, oh, there will be more people, which means there will be more 18 to 24. That's correct that there will be more 18 to 24, but there will also be more people, so percent-wise, it still can go up or down. We should look at other factors. So I would expect this number to be larger. Did anyone calculate? What do you guys have? It should not take this long to multiply two numbers on a calculator and add 60.35. I mean, that should be less than a minute, given your speed for texting, right? So your thumbs are evolved enough to type this extremely quickly. There is no thinking involved here. You just punch numbers to multiply and then add 60.35. Not sure why.
Is it 9.5?
Yes. And I already see that I don't like this model because this number should be smaller by all. It should be smaller because I don't know. Anyway, there are a few reasons. Another reason is medical development, because people live longer. 100,000 years ago, all people died in their 20s and 30s. Just 100,000 years ago. That's it. Everyone died in their 20s or 30s. And then moving even sooner than that, maybe 50,000, 20,000 years ago, people were still dying at that time. Because by that time, the teeth are out and, can't chew, and, animals catch up with you and kill you. It's like, it was, all of the elders were in 30s and then they would die quickly. So we went really far with medical advancements to keep people alive longer, and the longevity of the people is increasing. So we should have way more old people in 2050 than now in 2020. So that should offset this percent, and it should make sense for this percent to go down, not to go up. Now, we did the calculation. We know calculation is correct. We can say that it's a bad equation, right? And the way I would fix this equation, I would just put this into a plus, I guess, and then, do some other calculation over here to, fix it around, because it should not, it makes no sense to have more. Actually, no, wait, does this make this does make sense? What am I talking about?
Oh,
Yeah,
okay.
yeah. 2020 has more young people than 2050. Yeah. No, this does make sense. This is a good model. 9.85% in 2020, and 2050, 9.1%. No, this is good. Let me just write these numbers nicely. So 9.85. No, this is definitely good. We are expecting to have less, percentually less. So number-wise, there will be more than now, but you will have much more others, right? Older people. You will have much more older people than now, and that would drag the percent down. Okay, cool. So that was the other problems are solid waste. I guess that's garbage, yes. Web browser, HIV infections, and number of welfare beneficiaries. So, there are other problems that you can also look into, which have these data points that you can look into and see, whether the numbers go up or down, and then, think a little bit about the environment and, population. So that's it for this section 3.2, where we have two variable equation. If we have one of the numbers, we can compute the other number. If we do not have either of the two numbers, then all we can do is solve for the variable, and then the equation will be the solution. So that's it. I am going to now move to Zoom for review, if you have any questions for the upcoming exam this weekend.